Alright, in this video we're going to talk about simplifying algebraic expressions. In order to be able to simplify algebraic expressions correctly, you really need to understand the properties of real numbers. So if you're unfamiliar with the properties of real numbers, you might want to go back and take a look at those in the previous video. And you also need to understand the order of operations. So we also have a video that we created for that. So anyway, check those out if you have problems understanding this section. So let's go through several examples here of simplifying algebraic expressions and see if they make sense. All right, in example 1, we really just are adding and subtracting a bunch of terms. Again, we have to understand what terms are. So what I like to do is just kind of underline, let's talk about the x terms first. We have a 3x here. If we go down the list, we have another x term, and that's all we have. So how many x terms do we have? Well, we have two x terms, but we have a 3 as a coefficient and an 8, so that's a total of 11 x's. Let's go ahead and circle the y terms. There's a negative 4y term, and notice I circled the subtraction that's with that. It's not just a 4y, it's a negative 4y, and this isn't just a negative y, it's a negative 1y. So by combining them, we have negative 4y, we're subtracting another y, that's a total of minus 5y. And then finally we have the constants, negative 3 with a plus 5, so that's a total of plus 2. So as you can see that it's important that when we identify the terms, we also have to pay attention to the operation in front of those terms, because we treat those like the sign of the terms that follow them. So example number 2, let's take a look at that one. We have an m term, let's go ahead and underline that. And it's a negative 5m, and down at the end the last term is also an m term. So negative 5m with negative 9m make a total of negative 14m. And then the middle two are both n terms. One's a positive 11n, the other one is a negative 8n. Well, that's a total of a plus 3n. Now I'll do this with example number 2 just to show you that it's the same thing here. We have, if we do the n terms first, we're going to have still 3n. If we do the second, or combine the m term second, that's going to be a minus 14m. I want you to understand that these two answers, these two expressions that we wrote here, are exactly the same. So why are they the same? Because we talked about the commutative property of addition before, so the order of the terms doesn't matter as long as the signs are the same. So when we're looking at the 14m, for example, it's not just a 14m on the first algebraic expression, it's a negative 14m, and it likewise in the second algebraic expression it's also a negative 14m. And the three n's are both positive in both methods of writing the answer. Now the best answer, if there is a best answer, would be the first one, and the reason for that is we have what's called mathematical conventions, and the convention is to alphabetize the terms when you write them down, when you simplify them. So I mean, if I had a best example or best answer, that would be the negative 14m plus 3n. What about example number 3? Well, we have three terms. The first one is a p squared term, the second one is just a p term, and then we have an s term. This one is already simplified. There's nothing we can do with this expression. In other words, there are no terms that we can combine here. So what about example number 4? Was there anything we can do inside the parentheses? According to the order of operations, we want to start there. Well, in either set of parentheses, there are no like terms. 3x minus 2y plus 4, there's nothing we can do there. But what we can do is distribute the negative 5. So negative 5 times 3x is negative 15x. Now when I distribute to the second term, I'm going to call this not just 2y, but a negative 2y. So treat the operation in front of the term as the sign of that term. So negative 5 times a minus or a negative 2y is a positive 10y. And then finally, a minus 5 times a positive 4 is going to give us a minus 20. So now we can distribute across the second term. Now again, this is not just a 2, but it's a positive 2. So positive 2 times 3 is a positive 6, and a positive 2 times a negative 6y is a minus 12y, and a positive 2 times a negative 7x is a negative 14x. So we have distributed the outside factors to the terms inside, and now it's time to go through and combine the like terms. So alphabetizing this, we're going to put the x's together first. Let's go ahead and do that with lines. I have negative 15x and a negative 14x. That's a total of a negative 29x. I'll double underline my y terms. Just make sure I didn't forget anything. That's why I'm using these lines to help me understand what terms are like. So the y terms are like. We have a positive 10y with a negative 12y. That leaves us more negative by 2, so negative 2y. And then finally, we'll go ahead and circle the constant terms. Again, just a way of organizing and making sure I don't forget about any of my terms. A negative 20 plus 6 is a negative 14. So we simplified example number 4, and we have 3 terms left. Negative 29x minus 2y minus 14. Let's go ahead and take a look at a couple more examples here. I believe we have 6 examples. One thing you'll notice when you start looking at these, it can get confusing. There's a lot of stuff here. We just got to make sure we take our time and stick to the rules of algebra. This is similar to what we just did in the previous problem. We have nothing inside the parentheses that we can combine, no terms because they're not like terms, but we can distribute the outside term or the outside factor. 4 times 8p is 32p. 4 times a minus 7 is a minus, I should have said minus 7q. 4 times minus 7q is minus 28q. And then finally, 4 times a positive 2 is a positive 8. Now you got to be careful with this next example, or this next portion I should say, of this algebraic expression. We have a minus in front of a grouping. Anytime that happens, you want to make sure that you show a number there. The number is a 1. Essentially what's going to happen is the subtraction is going to change the sign of all of the terms within the parentheses. When you distribute, you'll see that. What's a negative 1 times a minus 10p? That's a plus 10p. A minus 1 times a plus 15q is a minus 15q. And finally, a minus 1 times a minus 6 is a plus 6. So once again, when you're looking at these signs of the terms, you'll notice that they all changed because we have to distribute the negative 1 in the front. All right, so once again, we're going to combine like terms. Let's start with the p's. We have a 32p and a plus 10p. That's a total of 42p. The q terms, we have a negative 28q and a minus 15q. Well, that's a total of minus 43q. And then the constants, we have a plus 8 and a plus 6. That's a total of a plus 14. All right, let's do one more example here. We have number 6. This one is a little different than the other example we looked at, or the others. So we got to be careful here. We want to make sure that we start with the innermost grouping. So the outside grouping is here, and we have 2 other types of groupings inside, parentheses here and here. So what we have to do is distribute. Remember, we have a minus in front of a grouping. You'll put a 1 there. So let's just bring everything else down. We have 5y minus 4. Then we have a bracket, 3x. Now we have to distribute the negative 1 to the 2y. That's minus 2y. Distribute the minus 1 to the minus x. That becomes a plus x. And then a minus 1 times a plus 1 is a minus 1. Now we can distribute the positive 2 to the x. That gives us a positive 2x. And then a positive 2 times a minus y is a minus 2y. So remember, we want to, if we can, simplify within the brackets. That's the grouping. So we have x terms, and we have 3 of them. So let's bring everything else down. We have 5y minus 4. We have a bracket. Now be careful with the signs in front of the terms. We have 3x plus an x, so we're up to 4x, plus 2 more x's is 6x. Now what about the y terms? The y terms, we have a minus 2y and another minus 2y. So that's a total of minus 4y. And then we only have one constant term within the brackets, and that's a minus 1. Now just so you know, if you wanted to distribute this negative 4 to each of those terms inside, you could have done that. I mean, that is legal. You're allowed to distribute if you want to. But I went ahead and simplified first. So if you distribute the negative 4 in the step above and finish finish simplifying your expression, you should get the same answer I get here. All right, so next, what do? Well, we can't simplify within the brackets. The order of operations, we have subtraction and multiplication. We have to multiply. So in this example, we do have to distribute that 4. Let's go ahead and change the color here. So we bring down the 5y, distribute the negative 4. Remember, this is not just a 4, it's a negative 4. Negative 4 times 6y is a minus 24x. I think I said that incorrectly. So negative 4 times 6x is a minus 24x. And a minus 4 times a minus 4y is a positive 16y. And then finally, a minus 4 times a minus 1 is a plus 4. So is there anything we can put together? Do we have any like terms? And yes, we do. We have the y terms that are the same, so we can combine those. But remember, the convention is to put the x terms first, so negative 24x. 5y plus 16y is a positive or a plus 21y, and then finally plus 4. So once again, the convention is to put the variables in order, alphabetically, and then we always put the constant term on the end. If you have them in a different order, again, that's not a problem. It's just we prefer to see it alphabetized. All right, so I guess that concludes simplifying algebraic expressions. I hope this all makes sense to you. If you have any questions, just let me know. Thanks.